Thanks, Marcus, and thanks everyone for coming. This announcement has been a long time in the making. Again, I'm Charlie Boyle. I run the DGX business at NVIDIA. And when we started this product a few years ago, as we launched the product, we had just a few simple goals. One, build the absolute fastest possible AI system that you could build. No compromises, high-end components, and make it easy to use, and ship something that data scientists could get productive with super quickly. And since then, we've shipped a lot of units, got thousands of customers worldwide in it. But the number one feature request that I had after I started shipping the product was, could you guys please support Red Hat on it? Because data scientists just want to get their work done. And while that's very important to them, and they don't care what the server looks like, what it is, can it run TensorFlow really fast? Can it run PyTorch really fast? They just want to get their work done. But it's a server. It's 3,000 watts. You got to put it in a rack somewhere. IT probably wants to touch it. And that was really the drive for a lot of our customer asks for Red Hat. And since then, we've, obviously NVIDIA and Red Hat have partnered together for a lot of years. But as I said, on the DGX platform, we want it to work well, we want it to work right and work out of the box. So, we've done an extensive engineering effort with Red Hat to make that possible so that, if the data scientist needs the software they need and the IT department, runs Red Hat internally, it's easy to integrate together. And that's what you'll see from the product. We're in beta right now, we'll be GA very soon, but that same great experience that you expect with, I just install Red Hat and then I add some packages, it becomes a fully functional DGX1, and IT gets what they need, and data scientists have what they need. It's been a journey. We wanted to do it right. We've had lots of customers say, oh, I just loaded Red Hat on my DGX1, it works just fine. We said, yes, we know that fundamentally works, but we're not just trying to build a server, we're trying to build an extremely fast deep learning system. So we wanted to go through all the QA, the testing, everything's in continuous regression testing as we update new drivers, all that stuff gets tested together, and that's the importance of the partnership. One thing, if you don't have a DGX system that I'll leave you with, that's a complete anomaly in the computer industry. Everyone in here has a laptop. Everyone's got a cell phone. Every time you download an update to one of those devices, what happens? It gets slower. You go, hey, we added some new features. It's only a little slower. Hey, we added some more features, just a little slower. In the DGX platform, with our software engineering on it, from the time that we've shipped a specific system, whether it was the original DGX1 with Pascal or the new DGX1 with Volta, we've doubled performance without changing hardware year on year. So that's a testament to our great software engineering teams and for all of our customers that believed in the early product. There's almost no system that I know on the market that gets faster over time, and we've continued to do that just in software. And now by bringing Red Hat on the platform as well, we're continuing that innovation, now giving you the choice to run what you've always run in your data center, which is Red Hat. So I just want to say a few words there. Super excited about the announcement. As I said, the team's been working long and hard to make this happen. It is a reality now. We've had great customers up and running on the software. We know it works, and that it'll be super easy to use as we GA it in the very near term here. So with that, let me turn it over to Andre to say a few words, and then we'll all be around for questions at the end.
Okay. Hi, can everyone hear me? Okay, great. Well, welcome everyone, and thank you, Charlie. I can say on behalf of Red Hat, we share the sentiment that this has been something that we've been working on for a while, and we're very happy to be able to support Red Hat products on DGX1. It's a very exciting time for us, and would like to just go through. I'm not going to be the main show. It's going to be the guy behind me here who's going to be getting down into the details. But just before Jeremy provides his update, I'm just going to go through just a quick overview of the relationship with NVIDIA and
Thank you for attending this session. Remember to complete.
Then we'll talk about some of the announcements that was made today, and then I'll transition into Jeremy to go over some of the details with regards to DGX, OpenShift, RHEL, and how do you tune that and configure it for what you need to do in terms of supporting your deployments. So as Charlie mentioned, we are announcing that the RHEL 7.5 specifically has been certified on DGX1. Okay, so this is something. First of all, does everyone know what certified means? It means that we have tested the solution on the NVIDIA hardware platform. It works. It's proven. It is supported, and we also provide a catalog update that shows that this solution is supported for our mutual customers. So customers want to see this. We'll provide it in writing, and then we'll continue to provide certification through the remaining releases in RHEL 7 as well. So doesn't just stop at 7.5. Okay, so this also means that we provide support for OpenShift. OpenShift is Red Hat Kubernetes offering. This is our premier tool, enterprise tool, for doing orchestration of your containers. And then once you have this platform on DGX, this Red Hat platform, you now can go into NGC, NVIDIA's cloud registry, and run any of the container applications that are available on there. So that will also be enabled. And then lastly, we're continuing to expand our relationship with NVIDIA. This was just one deliverable, but I think you'll begin to see more collaboration between the companies as well as upstream in the various communities that we're engaged in. And just to provide some data points on this relationship, I have a timeline here. This is actually the fourth GTC event that we have participated in as Red Hat as a company. It's the second one that we have provided sponsorship. So this year we did sponsorship at GTC DC as well as GTC San Jose. And I think it's been well worth the effort. We've had really good results. We've also invited NVIDIA to participate at the Red Hat Summit, which was this past May. And that was a very successful turnout. We did 2 sessions at the Red Hat Summit, again, promoting the partnership and our collaboration. We have also been collaborating on other products besides DGX with regards to some of the other offerings that NVIDIA provides. So I just want to make sure that once you leave here today, we have lineage, we have traction, and of course we're announcing today the RHEL on DGX support and certification. So this is a testament to the work that we're doing together. Just a quick couple of items on the open source collaboration. We have Nouveau driver. This is our driver that we support the NVIDIA GPUs. We have the heterogeneous memory management. That's probably one of the more exciting collaborations that we're doing. We have one of the Red Hat developers, Jerome Jalise, who's working upstream on supporting this. This will provide the ease of having access to the GPU memory, so other resources can use this. And there's going to be an advantage to developers that are programming with this access, as well as a benefit with regards to performance. So very important. We're doing work with GCC on support of the OpenMP Common Library, and then NVIDIA has done a lot of work upstream with mediated devices, and mediated devices supports their virtualized GPU offering. I know for a lot of folks in the public sector, security is paramount, and for a lot of our customers that use Red Hat enterprise solutions, they expect a certain level of security, stability, as well as scalability. And I just want to mention that when we had the Spectrum meltdown issue at the beginning of the year, that we were able to work with NVIDIA and ensuring that the patches we made available were tested before we released them to the public. And we were collaborating, and there was a lot of behind-the-scenes work done there to ensure that we had good stability and reduce the exposure that our customers would have with regards to some of these security vulnerabilities. So that's what I wanted to mention, just to leave that with you, and I'll let Jeremy get into some of the details with regards to our announcement today. Thank you.
Okay, hi guys. My name is Jeremy Eder. I'm on the performance and scale team at Red Hat, currently being blinded by the projector. Stick to one side of the room. Yeah, so unfortunately there's not much to say about installing RHEL on the DGX. When we got it in-house, it just sort of worked. Literally nothing to report, maybe a little bit of an overstep, but it's basically you turn it on, you install RHEL, everything works. So we just add that layer of certification on top of it. As I believe NVIDIA is working on documentation to actually have customers, with official docs on how to provision the server with RHEL on it. So, not much to say. Works great, awesome. What I wanted to say is okay, so now you've got the OS laid down. What other improvements can we make? So, for years, since the GA of RHEL 7 and also in RHEL 6, Red Hat has shipped a tuning profile delivery mechanism called TuneD. We'll continue to deliver that with CoreOS and some of our newer products like OpenShift. It's in OpenShift already. And so what this thing does is it tunes the operating system for a particular workload. In this scenario, it just so happens to fit some of the existing tuning that NVIDIA had already documented and discovered on the DGX, and they'll sort of fit that into the Red Hat mold a little bit more and ship a TuneD profile called DGX Performance, and I'll show you some of the guts of that in a second. The way the TuneD works is you've got this kind of inheritance, profiles of inheritance. Red Hat's defaults is called throughput performance. My laser beam's not working. And that's what makes RHEL feel like RHEL, is that's the way it's tuned, slightly different than the upstream kernel, data center focused knobs and tunings like VM background ratios and flush ratios and so forth. We also fiddle with some power management. From there, we descend into some child profiles, which are like additive. So you get the base profile throughput or base profile latency and so forth. You can customize it to things like a virtual host, which is what we lay down on KVM, or Rev hosts, Red Hat virtualization. And then you've got children or grandchildren where the green boxes are custom profiles. In this case, a DGX performance profile would fit as a child of throughput performance. So this is what the guts of it looks like. And that's how we tune RHEL up top. And right now we have, so DGX Performance right now is currently just a bunch of command line knobs. And eventually, and this is a good placeholder for any future stuff that, like Charlie was mentioning, we improve the product performance over time. We do the same thing at Red Hat. These knobs we turn at the top were not all found at one point, at one time. They were, we added to them over the 3 or 4 years that Red Hat Enterprise Linux 7 has been out. So that's that. Who here has heard of Kubernetes? Who here has used Kubernetes? Okay, a few people. Today might be actually a little bit Kubernetes sort of like advanced stuff, so I apologize if you haven't used it before, but I'm currently working on OpenShift, and the DGX RHEL base is where I'm assuming is just going to work, and I want to build on top of that to deliver AI and ML workflows that leverage NVIDIA hardware, as well as the CI/CD aspects of OpenShift, which is Red Hat's enterprise distribution of Kubernetes. So they made me put this in there, and it's a slide that indicates like the breakdown of the markets. I guess since we're in DC, you might be interested in the fact that government is currently 18% of OpenShift's market, 35% in financials, big businesses, security-conscious, performance-conscious customers. That's the summary of that. In addition to that, if you're looking to choose a Kubernetes platform, Red Hat's the second leading contributor behind Google, and we run everywhere that RHEL runs. So there's hundreds of certified cloud providers, obviously the 3 or 4 main ones, depending on what you consider main, but RHEL runs there. OpenShift also runs wherever RHEL runs. So pick and choose, bare metal, VMs, public cloud, whatever. Okay, so how did I end up here? This idea was conceived in early 2015. We wanted to deliver a high performance, what we're calling performance-sensitive application platform on top of Kubernetes. And so my world has been driving this roadmap in upstream Kube. What we found after doing some customer interviews was that most of these workloads had a lot of overlap. So what we did was basically these interviews, deduplicate, and implement those features in a priority order. So things like if you look at HPC market or big data or animation, financial services, like NFV stands for network function virtualization, that's a telecom workload, machine learning. These things all need roughly the same tuning. So and roughly the same like features exposed from the kernel or from the hardware. So we did a bunch of work, and I'll go into some of the details in a second. Okay, so when we talk about enabling the usage of the DGX, here's what it would look like in OpenShift. The most important thing to understand here is that you've got n number of nodes, and those nodes can be heterogeneous in nature, any kind, any shape. As long as they're running OpenShift, you will be able to schedule workloads onto them. And if we zoom in on, so like you've got these 6 OpenShift nodes on the top right, and let's add n number of DGX1s as OpenShift nodes. So if they run rel, you can install OpenShift on there, and they will become schedulable entities for your workloads that need GPUs. How are we doing so far? Okay. So Red Hat's upstream first. So what we did was, like, there was no vehicle to deliver this in upstream Kube. So we first had to create the vehicles for delivering those features. And that in Kubernetes land, that's like a special interest group or a working group in this scenario. And we created a resource management working group, and we delivered a bunch of features, including the key piece called the device plugin, which allows the GPUs to become known to Kubernetes. We also added CPU pinning and huge pages, which are, as I mentioned before, like there's a lot of overlap in these features, so you don't necessarily only use one, you kind of use 5 or 6 different things at the same time. We tried to knock all of these down one by one. Actually, incidentally, NVIDIA hosted the upstream community in March of this year. This resource management working group, we all went out to San Jose area and talked about the roadmap. So things on the roadmap are like NUMA, topology awareness, NVLink stuff. Yeah. In addition to that, we know that these devices have like 16 InfiniBand ports coming out the back. We have to figure out a way to enable that stuff in Kubernetes. So we're working with Mellanox on that. And so that'll be the hardware support. At the same time, we also have to teach Kubernetes to deal with n number of networks. So we created another working group full of smart networking people to figure out how to teach Kubernetes about multiple networks. Essentially, it'll be a data plane, a control plane, and a data plane type, at least in the initial cut. So that's that. Community stuff all the way, everything goes upstream first, back into Red Hat Enterprise Linux, upstream first, back into OpenShift. Cool. So here we are again, and again, this is the extent of my graphic design skills. But so we've got basically the kind of, this is the logical diagram of an OpenShift cluster. In the bottom left, you've got a heterogeneous environment. These gray boxes are just random compute nodes, right? Just a pizza box, or an AWS VM, and maybe it's not a DGX, it's an AWS VM that has GPUs in it, or a GCE VM. Who's using public cloud? All right, we'll just axe that. All bare metal, sounds good. So it is a DGX1 in your world, or maybe another server with some GPUs in it. How do we handle, so like if you're familiar with just distributed system scheduling for the last 30 years, not a lot new here, not a lot of patents being handed out, but we are building in features which enable the next generation of like containerization into OpenShift. And so we have a way to mark these nodes, these DGX nodes as special. Contains and tolerations, priority and preemption of some Kubernetes words for creating node pools, either with soft or hard partitioning, which is another question I have for you all at the end. I will ask. We're going to tune and configure the operating system with syscontrols and potentially CPU isolation, maybe not. And I went over TuneD. Oftentimes we'll find people allocating huge pages for use with these types of workloads, particularly like Spark and any other large Java type workload. You almost always see that on huge memory systems. And we can dedicate some CPU cores for it. So, okay. How do we light up the DGX? Obviously, we need to deploy the drivers, and we're working with NVIDIA on Kubernetes-friendly driver deployment. Let's just leave it at that. as well as deploy the device plugin itself. So the device plugin, as I mentioned earlier, is a way for, and NVIDIA wrote this code. It detects the hardware, and it informs Kubernetes that X number of GPUs are in this system. And then we can consume the device from, as a user, I say I need 4 pods. I'm going to show you a demo. If I don't run out of time, I'll show you a demo of consuming GPUs off of a DGX in OpenShift. OK, so here's where I was leading with the taints and tolerations and priority and preemption. So let's say we had a cluster with 10 regular nodes and 10 DGX. Would you want to drive density, or do you need to drive kind of isolation into this cluster? The difference between these two technologies is priority and preemption allows the cluster to be completely full. Stuff runs everywhere. There's no reserved nodes for anybody. And the opposite, taints and tolerations, allows you to carve out these node pools for business unit X, business unit Y, and so forth. So my question to you guys is, do you want to keep all the GPUs busy? What's more important? Just anyone care to jump in?
I mean, personally, I would like to keep maximum performance out of my hardware, but professionally, I know my government customers are going to care about the segregation, like isolating their environment to this server only hosts my stuff. So.
Yeah. Yeah, so the gentleman mentioned that there might be some security implications that you might want to logically partition a cluster. And the other option is, you can have multiple clusters. Then you've got a management issue, like if you had a bunch of VMware clusters running around, you have that sort of tiered issue to deal with. OK, that's good feedback. Appreciate it. I feel like there's no one answer. I was just wondering if, I just wonder if it's like 60-40 or like 90-10, that sort of thing. And so we do have some examples.
I mean, in the government space, I'd imagine most of the time it's going to be the government likes to keep their things secure.
Yeah. OK. Cool. Oh, you got a microphone?
Yeah.
OK. So if there's other, is it on?
Now it's on, I guess. Yeah. No?
It's on now. It's
Yeah.
on. OK, cool.
No, it's cool. We all love these interactive things, but yeah,
Yeah.
give a heads up for the microphone next
Will do.
time. Great.
Will do. Will do. Sorry. Just kind of, yeah. I love talking to customers, in case you can't tell, because if I don't talk to you, I feel like my team could end up wasting our time developing stuff people won't use. So I want to hear exactly what you need, and we will put something together. Okay. Cool. So that's that. This presentation has been delivered like 5 different times, but I don't think this audience has been covered so much. It was delivered last year at NVIDIA, again at Red Hat Summit. But this is the logical software diagram of what it takes the entire NVIDIA stack to stand it up and actually use it on Kubernetes. You can swap out OpenShift for Kubernetes. It's the same thing. We have an operating system at the bottom. In this scenario, we finally can call it supported Red Hat Enterprise Linux 7. We have a driver, obviously, libNVIDIA container. libNVIDIA container and the runtime hook are let's just say they're unique to NVIDIA right now. And in time, we expect those pieces to potentially fall off as we get new features up into OCI, which is the Open Container Initiative, and some upstream features. We can hopefully do away with some of the layers here. Not guaranteed, but potentially. So Linux container runtime, that's in Red Hat, that's CRI-O or Docker. Yeah, and then OpenShift container platform runs on top of Docker or CRI-O. And you've got this device plugin thing, which runs on all the nodes that have GPUs in them, and then you've got some pods on top. Does this diagram make sense? OK. Right now, we have a one-to-one relationship between pods and GPUs. So a pod can consume only 1 or more GPUs. It can't consume less than 1 GPU at the moment. If you have questions about GPU sharing, I'll need to refer you to the NVIDIA folks on that one. Cool. So OC create, OC is the OpenShift command line tool. And if I create a pod that requests a GPU, so if you look in the top left, this is what it looks like when you request a GPU. NVIDIA.com/GPU is the thing that the device plugin teaches Kubernetes about. And I ask for 8 GPUs in this scenario. because I have a DGX1, so I want to consume all of them. Eventually, all of these nodes, again, I apologize for my graphics design skill, but basically, after you do OC create, all of those GPUs are now part of your pod, and nobody else can use them. And the way it does that is the devices C group. The kubelet is the node agent. Not super important for this presentation, but essentially it's the thing that runs on every node that juggles all the C groups, that actually starts the containers, tells Docker what to do, and so forth. Yeah, so that's how that thing works. OK, let's go through a demo. I don't know if you can see that in the back, but the link to this will be in the slides if you want to watch it later. And this video is on YouTube already, so you'll be able to watch it. It's only about 3 minutes long. What I wanted to show here, what we wanted to show, was how you can use OpenShift CI/CD workflow to enable your data scientists access to DGX hardware. So what this environment is a single DGX1 appliance running OpenShift. The device plugin, the drivers, that whole stack I mentioned is installed there. And this is the web console for OpenShift. It's a developer-focused console. So we're going to log in. Super secret password is 12345. OK. And this is what you get when you log in. This is called the service catalog. Inside OpenShift, you can, they're called templates. And if I wanted to create a PHP and MySQL application, I can click on that button. And what OpenShift will do, you will point it at your Git repo. That includes your PHP source files, your database schema, whatever else, right? OpenShift will suck down your Git repo, glue it into a PHP and MySQL and RHEL container, and then deploy it for you. And then it will also manage things. Basically, if you have GitHub webhooks, that whole flow is automated. And obviously, you can have dev, stage, prod type of gates. It's actually a fairly complicated CI/CD environment that we've got. And by complicated, I mean featureful. So that's that. Let's continue on here. What we're showing in this scenario, so we've got the device plugin over here. A daemon set is a Kubernetes thing that means run on every node. In OpenShift or Kubernetes, we only want it to run on nodes that have GPUs in them. Right now, it runs on every node, and we're working to fix that. We'll have it fixed really soon. There's no harm in it running on a node without GPUs. It just is like a dangling thing that shouldn't exist. So, and the bottom is like OpenShift's whole control plane is self-hosted in pods themselves, and so these are not important. But the top is the device plugin based on Kubernetes 1.11. Again, is written and supported by NVIDIA. And there's one running, because I mentioned there's only one physical machine in this environment. Let's see if I can skip ahead a little bit. OK. So one of the things Red Hat contributed to Kubernetes was a thing called namespaces, which is just a logical group, like DNS, it's a namespace. It's a logical grouping of pods. In this scenario, before that daemon set thing was running in a namespace called kube system. That's where all the privileged stuff runs. Now I'm in the NVIDIA namespace, and that's where my user pods, my data scientist created a namespace called NVIDIA in this scenario. Could be a namespace called Jeremy, could be called GTC, whatever. So we'll go back to the service catalog. And what we're going to do is we're going to filter by NGC. And so what we did was we took NGC images. Who knows what has anyone actually used these NGC images? There's about a dozen. So if you go to ngc.nvidia.com, you'll get the NVIDIA GPU cloud. And what it is it's a Docker registry, container registry, and there's 12 or 13 optimized AI ML frameworks like TensorFlow, Caffe, PyTorch, and so forth. What we did was we took those base images, and we made them into those OpenShift templates I mentioned earlier, like that PHP and MySQL thing. We just created a couple of them for the demo here. Actually, we're going to commit examples of all of them to OpenShift. So anytime you install OpenShift, you'll have these examples at least not pre-populated, but you'll have the ability to install them. So in this, I'm just going to show inference, not deep learning, but I think the concept is important to show that we've got a totally web-based experience here. Of course, all this works on the command line as well, but we chose to do it in the UI here. So we're going to create the inference server first. And, oops. So you see here, part of our templating allows us to define where the models are actually stored on disk. This is a thing that gets bind mounted into the container. Could be on an EBS volume somewhere. Could be on an NFS share somewhere else. Gets bind mounted in. And we can select the number of GPUs to give it access to. I mentioned earlier it does that C group dance, the devices C group. So what it's going to do is it's going to take the first four unallocated GPUs and glue it into the devices C group for the pod that will be my inference server. Did I say that right? Yeah. Cool. So not super dramatic. It's actually already done. We'll prove it to you. Here's the TensorRT server pod running. And what we're going to do is so in OpenShift's web console, you can actually get a bash prompt on a pod. This is also possible from the command line, but we give you a nice web UI to do it. And this is impossible to read. I realize that, but you'll need to trust me. It found 4 GPUs. And what we're going to do is just curl. There's NVIDIA SMI, so there's 4 GPUs. And we're going to show you it curling curling a loopback address inside this pod, just to show you that the inference server itself is returning results. That's all. These are all APIs talking to each other, right? So just a curl, simple curl of the inference server. Next, we'll spin up a client of that inference server. So I'll go back to the filter by NGC, and I'm going to turn on a machine learning framework, in this case, Caffe. Again, this thing comes from NGC itself right now. I'm going to give it 4 GPUs, and I'm going to turn it on. I'll go into the console of this Caffe pod, and I will curl the inference server, just proving that the client, my machine learning framework, can actually talk to my inference server, which you'll see shortly. There's NVIDIA SMI again. So there's 4 different GPUs. There's 8 total in the DGX one. And there we are. So that's the Caffe pod talking to the inference server pod. So they can talk to each other. That's a complete application demo. Now you lay your code on top. Those things should be able to talk to each other. Good to go. So from an implementation standpoint and an enablement standpoint, that's a shooting match right there. And I think that may be the end of this demo. Yep. Cool. Does that make sense? Does that seem like something you'd be able to advocate for internally if you have a pool of data scientists who want to use DGX hardware? Potentially forward-looking people who are experimenting with containers. Sound like something they might be interested in?
That's something I'm trying to push forward right now in my workspace.
Yeah.
That looks really easy. It's just a matter of...
Yeah. So here's the thing, right? I was at a conference last week called Open FinTech in New York, and we heard Bloomberg present. And what they did was they had something similar to this. It was all command line driven, and they abstracted it even further. They only allowed their developers to select t-shirt sizes and only a very limited choice of language frameworks that were like, the standards in that institution. Great presentation, and what they did was like you're only allowed a small, medium, or large of PyTorch. That's it. And so they had it was command line driven, but my point here is that they internally built something kind of similar to what I'm showing you here, in that they've tried to standardize things to kind of keep the developers on the happy path, and like Charlie was saying, keep them as productive as possible, get the infrastructure out of the way. So, All right, I think I have a few more minutes left, so let me just finish up with some roadmap stuff. One of the things that when we originally engaged with, or when I originally engaged with NVIDIA, one of the things we heard and from our shared customers is like, on RHEL, we should have a top-notch experience throughout the stack. And that obviously includes OpenShift, which we're trying hard on. There's also operating system level work to do. NVIDIA themselves have you guys know they have their own driver thing. What we are attempting to engage even more deeply on is improving that driver packaging situation on top of RHEL. Has anyone heard of Negativo 17? Those are the drivers, this just dude in the basement put drivers together that were basically RHEL standard. And I think we ended up hiring him. Did we hire him, Ron? The Negativo guy? We ended up hiring this guy because he did such a great job at packing up NVIDIA drivers for RHEL. So it's evolved a lot from there, but we want to have a top-notch experience, and that includes all the quality assurance, testing, and so forth. So we are embarking on this project. It's not delivered at the moment, nor can I commit to any timeline, but that's occurring. So that's the type of thing that, as we engage more and more with NVIDIA and talk more and more publicly about these engineering things that we're going through, you'll see stuff like this pop up, which are just it may seem like a bump in the wire, but from a support standpoint, if we can improve people's experience, reduce support calls, make the whole thing seem more end-to-end kind of integrated, this is a worthwhile engineering activity. So that's that. And the last thing I wanted to mention are some other things. I mean, NVIDIA demoed a really slick Grafana interface to GPUs, which they currently have packaged only with Helm, which is a application manager for Kubernetes. That's what it looks like on the right, and it tells you kind of, actually, I think it's on the demo floor here. It might be on the demo floor. You might be able to go play with it. But they basically tell you if I have 1,000 GPUs in my environment, how do I make sense of that much hardware? And so they've got a nice graphical console. The reason it's not super friendly for Kubernetes right now is because these proposals on the left are not yet implemented upstream. We need to do a bunch of Kubernetes work in order to make Prometheus endpoints, for example, exposed off of the device plugin, so that Prometheus can talk to the device plugin and pull out the hardware health, which is currently like NVML. So that whole process needs to occur. We need to do a whole bunch of Kubernetes work, including resource APIs to give us more granular selection of hardware. You saw today that we only selected X number of GPUs. But what if you wanted to say, my application requires 24 gigs of GPU memory? Put me somewhere on a cluster where there's a single GPU with 24 gigs of memory. That's what the resource API will eventually deliver. Currently, you get a whole GPU, and that's it. And I mentioned topology awareness. If you've seen any of Jensen's presentations, you'll know that switch fabric and interconnects are the way to performance in this hardware. We need to bubble that topology information up into a user experience in Kubernetes. So these are things not just us and NVIDIA, but Google and Intel, and there's a lot of common interest there. IBM, Nokia, lots of people are interested in seeing that through. So